going to do is create an anchor chart. And I'm sorry the writing's crooked. It's straighter on yours, isn't it? Okay, I hope so. I'm going to create an anchor chart, and as I write, I want you to write what I write. Okay? So you're creating your own little anchor chart in your book. Our standard today is interpret products of whole numbers. That's the first part. What in the world does that mean? What does interpret mean? You may know what that means. I don't see that word very much in math. You know what it means? Well, I'll ask you later. Whole numbers are numbers that are not fractions or decimals. So like 6 is a whole number and 4 is a whole number, those kind of things. We're going to be talking about the word products. That'll come up. And then I'll see if you can figure out what that standard means, okay? First of all, we're going to read this problem. And as we read this problem, we're going to be talking about this second part of the standard. And I've been reading about this because it says on your sheet 5 times 7 means 5 groups of 7. And you know that is in our country, that's what it means. In other countries, they might have it backwards. But in our country, the United States, when we see 5 times 7, we mean 5 groups with 7 in each. And that's what this whole lesson is going to kind of lead to eventually. I don't think y'all have even gotten to this yet, so it's okay. This is not, we're going to try it together. Okay, so let's read this problem, and I'm going to probably have to model some stuff. I like to run, so as I try to run, I shouldn't say that, I'm thinking about a race. So this says the running club has 5 members. So if we're all in a club together, how many people are in my club? 5, right. And we're going to run a relay race. Do you know what a relay race is? What is that?
It's a race where 2 people are together and they both have to tie one of their foot together and they have to try.
Oh, you're thinking of the 3-legged race. I love that one too. I love that one. If you have a faster. Let me show you. Hey, come up here and help me. We're going to do a relay race. Come here and help me. Okay, you're going to stand right here. And I'm going to be running. Did y'all see? I saw this, the Olympics, and somebody dropped the baton. The person's holding the baton. Look that way. Okay, I'm going to run. And when I get to you, I'm handing you the baton. And then take that baton. And then she's going to run. And she's going to hand it to the next person, right? Does that make sense? So after all the people have run, they've run a long way, right? Okay, so watch. If they ran a relay race, okay, thank you for your help. Give her a hand, If they ran a relay race and each had to run 7 laps around the field to win. So that means I have to run 7, then I hand it to her. She runs 7, she hands it to the next person. How many times? Say it. 5. You don't have to, y'all don't have to raise your hand, you can just say it. How long would the race be? So if we want to win, how many laps do we have to run?
7.
So each person has to run 7. So it's got to be longer. So wait, we're going to turn this into an answer statement. How long would the race be? So how can we turn that into, we don't care about the answer, we're just going to put blank for the number. How can we turn this question into a statement? How long would the race be? Yes?
The race would be blank long.
Okay. I always put it at the bottom. You don't have to if you want to put it here, but I always put it at the bottom. So write this. The race would be, I probably should have put is, blank laps long. Put that? Okay. Okay, write this for me. Make sure you leave a line for the answer. The race would be blank laps. You still don't have a pencil. Hold on. It's all right. Write with it. A pen. Yes, you can do math with a pen. That's like kind of a special one too. What you looking for, baby? That's okay. Don't worry about it. Right. You ready? Okay, so that's what we're looking for. We're looking for how long the whole race will be. So I'm going to take you through model drawing, and I'm going to see if it makes sense to you. All right, it looks like y'all been doing some, or you've had some introduction to it. So let's talk about this problem. I'm going to draw one little box right here. And I want you to draw one too, just kind of small on your paper. Make sure you have enough room to write a number in it, because we're going to do that. That is a perfect size. I give him a pen that doesn't work. Will you get her pencil? Okay. Now, this stands for one of the people in the race. One of the members. So how many of these do I need to have to show the whole problem? Say it. 5. Okay, so it says the running club has 5 members. So we're going to draw 5 boxes, and I'm just going to connect them together. So I'm going to say 1, 2. Do I have enough? No. How many do I need?
5.
So go ahead and do that. Each one of these boxes stands for one person on the racing team or club. If that one doesn't work, just have her take notes. Oh, that's pretty messy. All right, now, the rest of the problem says if they ran a relay race, so here's the race, they're running long, and each had to run 7 laps around the field. So how far is this person having to run?
7 laps.
7 laps. Okay, so put that in there. How far is this person running? Just say it.
7.
7. How about this person?
7. 7.
Okay, do that for me. So each box stands for a person, and 7 stands for what? The laps. Okay, go ahead and draw that for me. Now, when you're doing model drawing, all of the parts add up to be the whole, which is what we're looking for. In this problem, it doesn't matter if you put the whole on the top or the bottom. I'm just going to put it right here. We're looking for how long would the race be. We're looking for how long this is. So go ahead and draw that for me. When you're in another grade, you might put a variable, like the teachers, your brothers and sisters, have you ever seen them solve with X and Y when they're older? Yes, no? Okay. Right now we're just putting a question mark. So that question mark is going to be what we're going to put right here. So how in the world are we going to solve that? What would you do? What would you do, baby?
I would add 7 plus 7 and 14.
Okay.
I would do Y.
Okay.
And I knew I had 7 left, so I added up to 14.
Okay.
14, and that's 24.
14 plus 14 is 20 what?
28.
That's okay.
And then I added the 7 and I got 35.
That's pretty good. So from this, you got 7 plus 7 plus 7 plus 7 plus 7. And she got 35. Agree? Disagree? Anybody do it a different way? What did you do?
I did base 10, so I did 1, 2, 3, 4, 10, and I did 1, 2, 3, 4, 5.
Oh, so you do. So how is the where's a base 10 from 7? Hold on. I'm going to come back to you and talk to you by yourself. I'll be back. Because we got to move on. Okay, so the answer is 35. Do you agree?
Yes.
You agree?
And I added, took away 1 10. And then took away 3 1.
Okay, hold that thought. I'll be back. But let me show you. Our standard says, who gave me this suggestion? Awesome. Did anybody else say that?
Me.
Did you? Okay, but our standard says we have to talk about products. And products, when we're talking about products, we're talking about multiplication. So I'm going to put, I need a different color and I don't know where I put it. Oh, this will work. Okay, products is multiplication. So I'm going to tell you what this one is. Real important that you pay attention to this. How many groups do we have? 2. Look, 1, 2, 3, 4, 5. And that's a person in real life, right? But it's a group in this problem because it's connected to Miles. So just trust me, we'll get this. There's 5 of these, so we're going to put 5 groups of, and how much is in each one?
7.
7. So 5 groups of 7 is, what did she say it was? 35. Write that for me. I'll put this back. But in math, we will say 5 groups of 7, but in math there's symbols that stand for things. So let me show you this one. Groups of, this is 5 times 7 equals 35. So whenever you are solving, whenever you get one of these, you can add them all up because that'll get you the answer. But eventually, when you've done it so many times, you'll find out that 5 groups of 7 is always 35, which is, ta-da, the product. This is called the product. So when we're talking about interpreting products of whole numbers, that means we're trying to find out what is the product of whole numbers. And these are whole numbers. These are also called factors. And I'm going to write that down. I don't think you have to know it right now for this standard, but I'm going to have some questions for you. So this and this are called factors. That's really crowded. I'm sorry. I should have worked that better. So I need a bigger chart. Okay. Now, so make sure you're caught up. Because if I ask you a product, I don't want you to say, huh? I want you to know the product is the answer when you multiply. But the main thing today is to know that 5 times 7 means 5 groups with 7 in each one. Now, I know you've not seen this before, so do not stress over it. But I'm going to give you some problems. And you're going to work on solving them with your partner. So your partner's going to be your person on your shoulder. So you two are partners. You two are partners. And then when you think you have it, talk to your group. What's the container? See where it says, what is the groups? I think I just told you. Is it the flowers or the pots?
Flowers.
So what's going to be in the flowers?
The pots.
Okay, what's going to be in the pots?
The flowers.
Does that make sense? So how many would you draw then? How many pots are there?
6.
Let's see if you can do that. See if this right here helps you. I don't know if it'll help you or not. See if you think that will help you some. Can you tell me why you did this instead of some people added 6 4 times? Where'd they get that? Why did y'all do this? You guys went straight to there, which is beautiful, by the way. Can you tell me how this relates to the model? Like if I told you to draw that picture, which I'm not telling you to do that. I just want. Could you draw that picture with these? Look at it. Could you? How many parts would there be? You have them right here.
Oh, it's 24.
You have the parts. How many parts would you have?
I would have 6.
Yeah. I'm not trying to trick you. You would have 6 parts, right? And what would be in each part? See if you can sketch that over here for me. Oh my goodness, I love this. Stop. You guys have the same with your partners. That works out good. But you guys have the same in your partners, but you're different. This is the perfect lesson for this. Look. Come up. I need you. Look. Which one of these shows me this problem? Only one of them does. You got the same answer though, didn't you?
Wait.
Where'd you get here? Wait a minute.
We got-
Wait, come here.
We got 6 and 6
Wait,
and
come here,
6
partner.
and 6. 8 and
You guys could not be partners because you have different answers. So how'd that happen?
Oh no, you have to do 6 and 6 and 6 and 6.
So what is 6 and 6 and 6 and 6?
30.
How do you get that?
I use this.
Okay, well show him. Don't erase that. Don't erase that. Don't erase it unless you agree.
3, 4, 5, 6.
We gotta make sure they have it. What'd you get for this? You solved it yet? You got 24?
Because 8 plus 8 is 16 and 8 is 16. 6.
I love it.
See this?
So put it in.
6.
Why did you add another 6?
4. 4 6s.
Now, that is the most beautiful picture. What is the equation for that? What says groups of? Like what number? How many groups are there?
There are 4 6.
They say 6. And y'all say 4.
Wait, but
I'm not telling you you're right or wrong. You can't change it. You can tell me what you're going to change it to and why. This is absolutely beautiful. So what did you guys decide the equation? Do you know what the multiplication for that is? Because that's what we're working on today. What do you think it is?
4 times 6.
Is it 4 groups of 6 or is it 6 groups of 4? If each one of these stands for a pot, how many goes in each pot?
Richard is asking
4. Yes, he is. See our standard? Look up there. It says we're doing the products. So I need to see what's the multiplication for this. How many groups are there?
There are 6.
Okay, show me. 6 groups of 4. Can you write it across this way? Can you write it horizontal? You can leave it there. Just write it up here so I can see it. Why is it not 4 groups of 6? Because somebody said it could be 4 groups of 6. Could it?
Yeah.
Why? Because you went to 6 times 4 like that.
If you knew this problem, you could.
If you changed the problem, you could, couldn't you? Who's reading the question? Okay, read it.
After the plants stir, all the pots
Contain.
contain full flowers. If you buy 6 pots, how many flowers will you have to plant? Does anybody
No, not yet. You hadn't told us what y'all did.
what we added 6 fours, then we made the fours into 3 groups of 8. Then we took 2 groups of 8, made it into 16. Then we added 16 and 8, and we got 24.
Look at that. They have 12 and 12. And then read us what you said on your bottom, the bottom part.
6 groups of 4.
How much is 6 groups of 4?
24.
Okay, write that down.
Can I lighten it up on that one?
Not yet. You remember you have to be very still. Pay attention. I need your help, Richard. Okay, now put the marker down. And remember I wanted y'all to use the word because. So tell us why you did 6 groups of 4.
Because when it said 4 flowers, and if you buy 6, usually when you're doing math, because it's multiplication table, you would do 4 times 6 times 4, and if you didn't know how that worked, you would put 6 fours down, add them up into groups, then take those groups, add them up into another group, and if there's anything left, add it to the last group, and you get your answer.
Thank you. Okay, say questions or connections.
Question or connection? Reagan?
Now read it loud or ask it loud.
What if you switch the factors around? Would that change your story problem? Sometimes it will, because my dad always told me that sometimes they may not be the same.
Okay. Do you know what she means when she says switch your factors around? What does that mean? Oh, look, she's like, your turn. Remember, if you don't know, you can ask her. She knows because she worked on it. No, the girl that asked you. If you're not understanding, say, I'm not sure what you mean, or something like that.
I'm trying to give her a turn.
Oh, okay. Well, do you know the answers? Then ask her.
Well, I don't think it will change your answer because all of my other math teachers, my first and second grade teachers,
Richard, how do you put it with this?
sometimes it doesn't matter because the order doesn't matter. Wow.
Okay, listen. What are the factors up there? Look on the anchor chart over there. Look on that one. What are the factors?
4 and 7, 5 and 7, and something. Yeah.
Okay, y'all don't lean on the board. Don't lean on the board. 5. So what are the factors over here? You just said it. Is Aiden? Is that your name? No. Aiden? I remembered. What are the factors on this problem?
9.
No, what are the factors? What are the factors, guys? Just say it. You don't.
Numbers.
The numbers. 4 and 6. So if you switch those around, does 4 times 6 still go with that story problem? Some people say, who says yes? Raise your hand. Who says no? Raise your hand. Who doesn't have a clue to do this? Okay, that's all right. You're not supposed to have a clue yet. Okay. Who thinks it does matter if you switch them around? You do, Aiden? Okay, why? Because see, you were telling your whole group that. You were saying it can't be 4 times 6. Why?
Because it's different. It's not like it's going to be the same number, but it's different because it's switched around.
It's going to be the same answer. Isn't that what you were saying, girlfriend, that asked the question? It does. Is 4 times 6 the same as 6 times 4 the answer?
No.
Yes.
What is 4 sixes if you add those up?
Well, 4 sixes, it would be 24.
Oh my goodness. And there's a property, I think, coming up soon for you guys that says you can switch those around and still get the same answer. But only one of those goes with this story problem. It's okay if you don't know now, but you will. That's part of what you need to know when you're doing multiplication. You need to know that is 6 groups of 4. So if you switch it around, you can't really do that. And I'm not going to tell you why now. Okay, somebody else have a question?
Yes, Miracle? What do you know? How do you know this is a multiplication problem? The reason I know that is because you see how there is an X. That is and if you have like, say you have 10, 4, and you need to add them up, and you can't figure out how. So then you would write down 10 times 4, and then you would be like, you would draw out 10 4, then you would add them into groups, and
It's because it's repeated addition.
until you got your final answer. And if you
Wait, stop for just a minute. Miracle, is she answering your question?
not really.
Okay, so think about it. And it's okay. I thought it was really good that you know if you had that sign there, it means you multiply. That's good. But when I read a problem like this, how do I know it's multiply? And you might not know yet, that's okay. But look at how many times you added 4. How many times did you add 4?
6 times.
So how many groups of 4 do you have? So whenever you have groups of, just think you're going to get that sign. It's really not an X. Well, anyway, it's okay. Anybody else have a question? I gave like 4 or 5, 6 questions out. Can you read this?
What does each part
Represent.
represent?
What does each part represent? Look in your box up there. What does each one of those stand for? And these girls right here and this guy right here, they know. So be ready.
One of them standing for one of these groups.
Okay, hold on. But what is each one? What is a group in this problem? The problem you're doing, what is a group? No, let her answer it. You know? Look at your paper. What are the groups? You knew when you were at your table. Is it when you're looking at all these people? Yeah. Just try not to look at them. That's what I do. Who can help us with this? This whole group knew. What does each one of those little parts stand for? Do you know? What do you think it stands for?
Numbers.
They are numbers, but we don't just have numbers in this problem. You three, we just talked about this. We spent 5 minutes talking about this. What does each part represent? What do you think?
I was just going to say, can I use the bathroom?
Not right now. What does each part represent?
The total?
Well, the total's 24. What does each box that has 4 in it stand for? Look at your problem. Everybody look at your problem right now. What does each part stand for?
6.
There's 6 of them. What are they? You know, Richard. What are those things, those boxes? You drew them over there.
They're pots.
They're pots. Thank you. I would give you 5, but I'm not. Okay, good job. So each part stands for a pot. You need to just keep going back in your story problem and figure out what does it mean. I know this is new for you, but this right here is a big standard for 3rd grade. You need to know exactly how to read a story problem and write an equation, which I think y'all haven't done multiplication at all yet, have they? Okay, that's all right.
I have.
You have? Okay, good. Because that problem where you're adding 4 6 times goes with that equation right under it. And that's how you'll know it's a multiplication problem. We had a couple more questions, but I'm not going to worry about them. Let's give these girls a round of applause. So awesome, awesome, awesome.